All right, let's take a look at an example. Here we have a number line, and I've placed the blue runner at the positive 2 meter mark. We'll take a look at a motion that this runner performs. We'll see how long it takes them, and we'll try and figure out the average speed and the average velocity. So at first, the runner runs from the positive 2 meter mark to the negative 3 meter mark, then continues backwards, traveling to the negative 6 meter mark, turns around and runs all the way past 0, ends at the positive 6 meter mark, and then finally runs back and ends at the positive 1 meter mark. Let's assume the whole thing takes 5 seconds. This is a very fast runner. The question we have is, what is the average speed and what is the average velocity of the runner? Remember, average speed being the rate at which they were actually moving over the ground, and the average velocity essentially being the rate at which they were moving from their starting to ending position. As with our previous examples, I like to look at the individual steps. So we know that the first step was actually -5. I said to double check, -5, then a -3, then a positive 12, and then a -5. So if you use the number line, you can arrive at those values. So now that I know those 4 distinct steps, it's just a matter of recognizing that speed is a scalar, which means I can ignore the directions. Or if I'm trying to find distance, which speed is based on, I can essentially ignore that. So the distance in this case would just be the 5, the 3, the 12, and the 5 added all together, ignoring all of the, I don't know why my numbers, I'm going to show both because apparently I wrote the numbers on the other slide. So for average speed, you're going to take your total distance, you're going to divide it by that time. So it's 25 meters because I ignore the directional component, 5 seconds. That average speed of that runner was 5 meters per second. However, they started at the 2 meter mark. They ended at the 1 meter mark, so they didn't really go that far, but they spent a lot of time in locations that were not between those 2 points. So their average velocity should be very low because they spent a lot of time going back and forth when at the end of the day, all they really did was take 1 step to the left. So now to calculate the average velocity, we need to base it on displacement. So now I need to account for these positives and negatives. So -5 plus a -3 plus a positive 12 plus a -5 gives me -1. If I divide that by the 5 seconds of time, I'm going to get -0.2 meters per second. The negative showing they're actually moving backwards or to the left, however you want to say that. And again, it was a very low rate because rather than just taking 1 step and getting there fairly quickly, they spent a lot of time going back and forth. One last thing I would like to show you guys is that to find the displacement, you can certainly add up all of those values, accounting for the positives and negatives. You can also remember that the displacement is quite simply the difference, straight line difference, between the starting and ending point. So this person ended at the positive 1 mark. They began at the positive 2 mark. So I could technically just find the difference between those two, the final minus the initial. So 1 minus 2, 1 being the ending point and 2 being the starting point, gives me -1, which you'll see is the exact displacement I got when I took into account all of those steps. Again, either one is fine. I like the straight subtraction of starting and ending point, but whatever you feel most comfortable with is fine with me.